So of course the first step of the root locus plot is to determine zeros and poles for a is equal to 0. So we'll take the characteristic equation, and of course we don't have this term here, and we will solve this third order polynomial for equal to 0. And we get three poles of our root locus or of our transfer function, which is s1 is equal to 0, s2 is equal to minus 3, and s3 is equal to minus 6. So let's put these three poles on our root locus. So we have minus 6 for a is equal to 0, minus 3 for a is equal to 0, and 0 for a is equal to 0. Of course, the second step is to get the root locus for on the real axis. So as we can see, this real axis is divided into four parts. S is higher than 0, S is between minus 3 and 0, S is between minus 6 and minus 3, and S is smaller than minus 6. So of course, we'll be focusing on this equation h prime g prime, which is 10 over s times s2 plus 9s plus 18. So let's start with s is higher than 0, so I will take a test point s here. And of course, the angle of hg is equal to the angle of s minus s1 minus the angle s minus s2 minus the angle of s minus s3. So s minus s1, so s1 is equal to 0. So it is a vector like that, and the angle of it is 0. S minus s2 is also a vector like that, and its angle is 0. And s minus s3 is also a vector from minus 6 to s, and has also an angle of 0. So the total angle is 0, and we know that this part of the real axis does not belong to the root loci. The second part is to take an s point, a test point which is here between minus 3 and 0, and we will also compute the same angle. So this is s minus s1, or the angle of it is pi or minus pi. S plus 3 is this angle, is this vector with an angle of 0, and s plus 6 is this vector with an angle of 0 also. So we can conclude, so the total angle is equal to minus pi, and we can conclude that the branch from minus 3 till 0 belongs to the root loci. We'll do the same for the vector which for a point which is here. So of course, s minus s1, it has an angle of 0, s minus s2 is also has an angle of 0, and s